picture the port of Rotterdam for a second. It's the largest port in Europe, and every single year it processes over 470 million tons of cargo.
Which is just a staggering amount.
Right. It's an almost incomprehensible amount of physical goods moving through this dizzyingly complex logistical web. And if you're a European business leader or a CTO listening right now, you're probably looking at that workflow and thinking about automation. You kind of have to be.
Oh, absolutely. It's top of mind for everyone.
But here is the massive roadblock. How do you possibly automate that level of complexity without running directly afoul of the EU's incredibly strict new AI laws?
Yeah, that's the real challenge.
Because, I mean, there's a big difference between a minor paperwork error and accidentally routing undocumented explosives through Europe's busiest trade hub.
Exactly. And the stakes couldn't really be higher.
So that's exactly what we're getting into today for this deep dive on the AI Insights by AetherLink channel. I'm your host, and our mission today is to extract the actionable blueprints from AetherLink's latest research on Agentic AI and Multi-Agent Systems. We're going to figure out how enterprises are actually pulling this off.
And I'm thrilled to be here as your AI strategist to help unpack this, because we really need to establish why this matters so urgently for you, the listener, right at this exact moment.
Right, because the timeline is tight.
It is. The EU AI Act is already in effect, and it becomes fully enforceable by 2026, which, sounds like a comfortable buffer.
It does sound like plenty of time.
But it absolutely isn't. According to Gartner's 2024 AI Governance Survey, a staggering 72% of European enterprises still lack comprehensive AI governance frameworks.
Wow. Wait, 72%?
Yeah, 72%. They are essentially flying blind into the most heavily regulated technology landscape in history.
That is a massive blind spot. I mean, looking at the current state of enterprise AI, it feels exactly like a country trying to build a high-speed rail network. Everyone's absolutely obsessed with fast trains, the new AI models, the generative capabilities.
It's all the flashy stuff.
Exactly. But 72% of these builders haven't figured out how to lay down the tracks or install the signaling systems. They're accelerating these incredible machines without the governance required to stop them from crashing into each other.
That's a great way to put it. Taking your high-speed rail analogy a step further, the regulatory environment is the actual terrain you're building on. You can't just lay track wherever you want.
Yeah, definitely not.
So this creates an incredible duality in the market right now. On one side, you have massive compliance risks, the kind of regulatory exposure that leads to severe financial penalties.
Not to mention reputational damage.
Right. But on the flip side, because so many are lagging behind, there's a massive competitive advantage waiting for the organizations that act early. Getting your infrastructure compliant today is what's driving the whole technological shift from traditional automation to agentic AI.
Let's actually establish that baseline because, the terminology gets thrown around a lot. For years, the gold standard for enterprise efficiency was RPA, or robotic process automation.
Right, the classic bots.
Yeah, but RPA is fundamentally rigid. It's strictly rule-based, like if X happens, do Y. It's great for moving data between identically formatted spreadsheets.
Oh yeah, very predictable tasks.
But the second it encounters a typo or an unexpected cell, it just breaks. Agentic AI operates completely differently. These systems use reasoning loops, taking in real-time feedback, adapting, and making decisions to handle actual ambiguity.
And what's fascinating here is why this shift is happening so quickly. Traditional RPA simply fails in knowledge-intensive processes. Like, think about compliance verification at a port.
Right. It's never perfectly clean data.
It's exactly. A shipping manifest from an international supplier isn't always perfectly formatted. The chemical name for a hazardous material might be spelled slightly differently or categorized under a regional trade name.
Which would totally crash an RPA bot.
Yep. A rule-based bot looks at that, doesn't find a perfect match in its database, and either crashes or flags it for a human. An agentic AI system, however, can look at that novel scenario, reason through the context of the document, cross-reference the chemical properties, and adapt its approach.
It behaves much more like a human analyst parsing messy information.
Exactly. It learns from the feedback it receives.
And the market is clearly recognizing that capability. If we look at the source material, there's a 2024 McKinsey report stating that 64% of surveyed enterprises are now actively piloting or deploying agentic workflows.
That's a huge jump.
It is. In 2022, that number was only 31%, so it's more than doubled in 2 years because companies are finally seeing quantifiable returns on investment. It's no longer just a theoretical lab experiment.
No, it's very real. It reflects the fact that the underlying frameworks have matured and the friction to implement them has dropped. But as you start scaling these reasoning loops across an entire enterprise, you run into a very real architectural challenge.
Okay, let's unpack this, because this is exactly where my alarm bells start ringing.
Oh, how so?
Well, if these AI agents are autonomous, right, if they're employing reasoning loops and adapting on the fly to new information, how on earth do we keep them from going rogue?
That's the big question.
Especially in a highly regulated environment like a shipping hub. I mean, if I'm a CTO, the idea of an autonomous black box making unregulated decisions about toxic chemicals is literally my worst nightmare.
And it should be. That leads us directly into the solution that EtherDV architects, which is multi-agent systems, and the concept of an agent mesh.
Okay, an agent mesh.
Yeah, you don't build one massive omnipotent AI that tries to do everything, because that's exactly how you get unpredictable black box behavior.
Right, the God model approach.
Exactly. Instead, you build an ecosystem of highly specialized, decentralized agents. In the context of a Rotterdam logistics deployment, you wouldn't have one AI handling the whole port. You have distinct roles.
Like what? Give me some examples.
Well, for example, you have a cargo classification agent whose only job, literally its only job, is to analyze manifest data and assign hazard categories strictly according to EU rules.
Okay, so highly focused.
Right. Then, operating entirely separately, you have a route optimization agent. That one calculates fuel-efficient paths based on real-time port congestion and weather.
Got it. And you'd probably also have like a compliance verification agent cross-referencing shipments against international sanctions lists, right?
Yes, exactly.
And maybe a cost allocation agent handling the real-time billing. So they're distinct entities with narrow, testable focuses. It's exactly like a well-run corporate office.
That's a perfect way to visualize it.
Like, you wouldn't hire a CEO and expect them to personally screen the hazardous materials, plan the delivery routes, check the legal compliance, and do the accounting.
They'd fail miserably.
Right. You have specialized departments, but here's the friction point for me. If you decentralize them, don't you introduce a massive communication lag? How do these departments share data without bottlenecking the whole operation?
To solve that, you need specific underlying infrastructure for your agent mesh. To get those specialized agent nodes to communicate seamlessly, you use an event bus. Technologies like Apache Kafka, for example.
Okay, Kafka.
Yeah, and you can think of Kafka less like a direct phone call between agents where one has to wait for the other to pick up, and more like a highly organized, high-speed central bulletin board.
Right, so asynchronous communication.
Exactly. The cargo agent identifies a hazardous chemical, pins a note to the bulletin board saying hazardous material found on Manifest 402, and immediately goes back to reading the next document.
It doesn't wait for a response?
Nope. The route agent, who is constantly monitoring that board for updates, sees the note and instantly recalculates the ship's path to a specialized hazmat terminal. No one is waiting around on hold.
That definitely solves the communication speed. But what about the accuracy of the information they're using? Like, how do we know the cargo agent and the compliance agent are interpreting the EU rules the exact same way?
That is where the shared context layer comes in. This typically involves vector databases and retrieval augmented generation, or RG. It basically acts as the shared memory for the entire system.
I want to pause on vector databases for a second because it's a term that gets thrown around like magic lately.
It really does.
From my understanding, a traditional database looks for exact keyword matches, but a vector database turns concepts into coordinates in a multidimensional mathematical space.
Exactly.
So if the shared context layer has the EU rulebook in it, concepts like toxic, flammable, and corrosive all live in the same mathematical neighborhood. When an agent searches for rules on a weird new chemical, it isn't just looking for the exact word, it's finding everything conceptually related to its properties.
That is a great breakdown of how our RAG fundamentally changes data retrieval. Every single agent in the mesh is drawing from that same mathematically mapped company handbook to ensure absolute consistency.
Makes sense.
And wrapping around all of this, the nodes, the event bus, the shared context, is the governance layer. This is where policy enforcement is applied uniformly across every single agent in the network. This architecture is what allows you to scale up to 50 or more agents without proportional increases in chaos.
Which brings us to the regulations themselves, because these multi-agent logistics systems fundamentally impact critical infrastructure, right? So the EU AI Act classifies them as high risk.
Yes, that high-risk designation is crucial.
And just to reiterate the timeline for you listening, full enforcement hits in 2026. If your system is high risk, you have a massive checklist of non-negotiable compliance requirements.
So what a list.
You have risk assessment documentation, transparency, human-in-the-loop protocols, GDPR alignment, data provenance tracking. I mean, it's an engineering headache just looking at the list.
It is a massive undertaking, which is exactly why AetherLink's AI lead architecture relies on a philosophy called compliance by design. You simply can't bolt these requirements onto a system after it's built.
You have to build it in from day one.
Right. Remember that modular agent design we just discussed? That inherently solves part of the regulation by isolating risk. If the root optimization agent hallucinates a bad path, it doesn't corrupt the compliance agent's sanctions check.
Oh, that's a good point.
Furthermore, the regulation demands transparency and explainability. To satisfy that, you need tamper-proof decision logging. Every single input, the agent's step-by-step reasoning, and the final output must be recorded for regulatory audits. And crucially, to satisfy the human-in-the-loop requirement, you implement confidence thresholds.
Okay, let me push back heavily on this human-in-the-loop requirement, because theoretically it makes perfect sense.
Sure.
But practically, if every single time an AI gets slightly confused, it escalates the decision to a human supervisor, haven't we just created a massive, expensive bottleneck?
It's a valid concern.
Yeah. Like, I've seen systems where humans get hit with so many alerts, they experience alert fatigue. They just start blindly clicking approve to clear their inbox. That completely defeats the purpose of the compliance check and the automation.
Alert fatigue is a very real operational threat. If your system is just crying wolf all day, it fails. That's why confidence thresholds aren't just arbitrary guesses. They are mathematically calibrated probability distributions.
So it's based on hard math.
Exactly. The agent calculates the statistical likelihood that its classification is correct based on its training data. If it's 99% confident, it logs the decision and moves on.
Okay.
If it hits an ambiguous edge case, say, badly translated manifest, where the confidence drops to 85%, only then does it pause and route that specific highlighted discrepancy to a human.
So the UI isn't just saying, hey, check my work. It's saying, I'm confident about these 40 items, but line item 12 contradicts our sanctions database. Please advise.
Exactly. And you aren't building those evaluation layers from scratch. Frameworks like LangChain, which, according to Redpoint Global's Q4 2024 metrics, powers multi-agent deployments across 40% of the Fortune 500, they automate that logging and routing seamlessly in the background.
So the audit trail is just generated automatically.
Yes, without human effort. The human's role fundamentally changes from a manual data processor to a strategic auditor, handling only the truly ambiguous high-value exceptions.
But wait, if we have an ecosystem of like 50 agents constantly talking to each other, accessing shared memory, and running these complex reasoning loops, every single time an LLM like GPT-4 or Claude processes a thought, it costs money.
Oh, yeah.
Aren't we just trading regulatory fines for a massive bankrupting cloud computing bill? Here's where it gets really interesting.
You've hit on the biggest hidden trap of enterprise AI. If you use a frontier LLM for every single micro-decision in a multi-agent network, your insurance costs will utterly destroy your ROI.
Which explains the massive shift towards small language models, or SLMs. We're talking about models like Phi-3, Mistral 7B, and Llama 2.
Right.
A 2024 Forrester report actually states that 58% of enterprises plan to shift 40% or more of their AI workloads to SLMs or edge devices by 2026. The advantages are staggering.
The cost savings alone are huge.
Yeah. Because you aren't paying per token API fees to a massive cloud provider, you're looking at a 50 to 75% cost reduction. You get sub-second latency for real-time decisions. And crucially, for the EU AI Act and GDPR, you get data sovereignty because you can run these smaller models entirely on your own local servers.
This leads perfectly to what we call the hybrid model strategy for cost optimization. You don't have to choose strictly between LLMs and SLMs. You use both strategically.
How does that work in practice?
You deploy fine-tuned SLMs to handle the deterministic, high-volume tasks.
Right.
Things like basic data classification, extracting entities from a document, or formatting text.
Okay, the repetitive stuff.
Exactly. Because they are highly specialized, they often outperform general LLMs on those specific tasks while using a fraction of the compute power. Then you strictly reserve your expensive LLM calls for the highly ambiguous reasoning tasks that truly require a massive knowledge base.
It's like running a legal department. You wouldn't hire a high-priced corporate lawyer who bills at €1,000 an hour to sit in the mailroom and sort the daily incoming letters.
No, you definitely wouldn't.
You hire efficient mailroom clerks. Those are your SLMs. They sort everything quickly, cheaply, and securely. And when they find a complex legal threat or a confusing contract, then they escalate it to the high-priced lawyer, the LLM.
That analogy is spot on. And beyond just model selection, there are other architectural optimizations to keep costs down. For instance, agent pooling and batching.
What does that mean exactly?
Well, instead of an agent sending 1,000 individual requests to an LLM every time a new cargo container is scanned, you group similar decisions together to reduce the API overhead.
Oh, smart.
You also use prompt optimization specifically, relying on few-shot examples.
Could you break down few-shot for us? How does that actually save money?
Sure. Instead of writing a massive verbose paragraph of instructions telling the AI how to behave, which eats up a lot of tokens and tokens equal money, you just show it 3 or 4 highly structured examples of the correct input and output.
Oh, and it just learns by example.
Exactly. The model recognizes the pattern instantly. That technique alone can reduce your token consumption by 30 to 50% without dropping any quality in the output.
Wow, 30 to 50% is massive. All right, so we've covered the theory, the architecture, and the economics, but CTOs and business leaders want concrete proof.
As they should.
Let's look at the actual real-world ROI from a case study in the source material. A Rotterdam Port Authority compliance agent built by AetherLink. Let's lay out the sheer scale of the challenge first.
Go for it.
The port processes roughly 40,000 cargo declarations every single month across more than 180 shipping lines. Doing manual compliance verification took over 800 labor hours a month. And because humans get tired, human error meant they were missing about 2 to 3% of violations.
And in the logistics world, missing a 2% violation rate on sanctions or hazardous materials isn't just an oops moment. It triggers massive regulatory investigations, staggering fines, and potential suspension of operating licenses. It is a highly consequential error rate.
So AetherLink deploys a multi-agent system to tackle this. They use a finely tuned SLM as a sanctions screening agent to do the heavy, repetitive lifting.
Right, the mailroom clerk.
Exactly. They use a larger LLM-backed hazmat classification agent for the complex reasoning. They add a customs preclearance agent, and finally, an escalation coordinator agent to route the tough cases to the human auditors we talked about earlier.
A full agent mesh.
Yes. And the outcomes, measured 6 months post-deployment, are incredible. The time it took to process a single declaration dropped from 12 minutes down to 1.5 minutes. That's an 87.5% efficiency gain.
That's huge.
And accuracy improved from 97% to 99.8%.
The financial impact of closing that 2% accuracy gap is profound. By preventing those violations from slipping through, they saved approximately €420,000 annually in regulatory penalties alone.
And when you combine the saved labor hours and the prevented fines, the total annual operational savings exceeded €680,000. They achieved full ROI on the entire system build in just 11 months.
Under a year.
Yeah. But obviously the $680,000 is great for the balance sheet. So what does this all mean for the everyday workflow of the logistics company? What happened to the workers doing those 800 hours of manual checks?
If we connect this to the bigger picture, the most transformative outcome isn't just the monetary savings, it's the human element. The human specialists who were previously spending 800 hours a month doing mind-numbing routine screening were completely redeployed.
Where did they go?
They moved to high-value strategic compliance audits. You're taking your most knowledgeable people and letting them actually use their expertise to investigate the complex anomalies the AI flagged. This massively boosts talent retention, reduces burnout, all while maintaining absolute mathematically provable compliance with the EU AI Act.
It's the dream scenario for enterprise automation. You aren't replacing the human, you're elevating them. All right, well, it's time to land the plane and wrap up this deep dive. If you had to distill everything we've covered into a single critical takeaway for the listener, what is it?
My number one takeaway is that governance and compliance can no longer be an afterthought or a phase 2 of your AI strategy. If you're operating under the 2026 EU AI Act, compliance by design, using modular agent architectures and local SLMs, is the only mathematically and legally sound way to scale high-risk systems. You simply have to build the tracks before you launch the train.
That's a great point. And my number one takeaway is the sheer speed of the ROI. We often think of enterprise AI as this massive, multi-year, black hole capital expenditure, but the fact that a conservative logistics deployment can yield an 11-month ROI while actively preventing six-figure regulatory fines means that agentic AI is a baseline competitive necessity, not just an innovation experiment.
Absolutely.
If you aren't doing this, your competitors already are, and their operational margins will simply erase yours.
Before we go, I want to leave you with a final thought to mull over. Something looking just a bit further over the horizon.
Okay, let's hear it.
As these multi-agent systems scale and become the standard, they're going to start interacting not just internally, but with the AI agents of external suppliers, logistics partners, and even customs agencies. When that happens, how will businesses resolve machine-to-machine disputes?
Oh, wow. That's a wild thought.
Right. If your perfectly compliant internal agent disagrees with the supplier's autonomous agent over a hazard classification, who wins? And how do you audit a disagreement between two completely autonomous competing networks?
That's a whole new frontier of digital diplomacy right there. We finally got the high-speed trains running smoothly on our own tracks, but soon we have to figure out how they connect to the rest of the world's network without derailing. For more AI insights, visit etherlink.ai.